we want to know the meaning of this limit, right? So maybe let's say what is it? What is the limit? Uh, how do you apply it, and maybe where exactly is needed, right? So these are some of the things that we are going to explain relating to a limit in calculus. We all need something. What I mean by that is that I need this marker to write on the whiteboard, right? And then maybe you also need a phone, any type of phone for communication. And then as well as maybe you may need a TV set, right? So maybe a television to just to visualize and maybe watch your favorite novellas and football and so on. But why do we need this limit? Where exactly do we need this limit? That is the most important thing here. So we need this limit in mathematics for a prediction, right? So prediction. Is that okay? To predict something, to predict where exactly can we predict? So we predict something that we've not seen, right? So the meaning of this limit is what our best prediction. Okay, so the best prediction of something that we did not observe, right? Something that we did not see. So maybe assuming you are watching a football, right? So maybe let's say I'm a football fan. So maybe if you watch a telenovela and there's something or series of that nature, uh, let's say around a certain minute, right? Around 30 minutes. So let's restrict ourselves to a football, right? So you are watching this thing. So you are watching a football. So around let's say 39th minute, right? And then uh, there's a buffering. So maybe a chopping network issue. So Banya, you didn't see what happens in between 39th and maybe let's say uh, like 41 minutes, right? So for in between these two things, you did not see what happened. So what is here, right? Maybe because of network issue, some buffering, and then other stuff, right? So you do not see what happens in between. Now, this is where the limit comes in. So the limit helps us to predict our best assumption on where is that, what happened if there was a goal, there was a foul, or where was the ball within this minute, right? So within this minute, you can see that in the 40th minute, something we did not see what happened here, right? So in the 40th, or maybe uh, close to that, maybe that can be 39 point something, or maybe 41. Let's say 39.09999 or 39.999. We did not see what happens at the point of fault. So that is where the limit is very, very important in this book. So how do you predict? So anything that we can see within this period here. So let's assume 39 point, let's say 9999, right? So up to something point. So this thing can be up to like 39.9999999. This is just an assumption, right? So in between, of course, it's not up to this 40 or it's not even up to 41. So anything that we can predict within this short period is accepted, right? So it's assumed to be true, right? Okay. So the best assumption that we can zoom. How best can we zoom in here for us to have an accurate or prediction, right? So you don't need to be right or correct to show that produce. So far as you are following what within this period here, you are free to go. So what does that mean in mathematics here? So if you have, or why is it important for us to do this? When math has something we call a black hole, right? So let's say a black hole. If this is a black hole, what I mean by a black hole here is that division by zero, right? So let's say if you have, okay, before that, let's deal with the numbers. If you have 2 on 0, this is not possible in mathematics in some cases, right? You cannot divide or you cannot share any $2. So a zero, nobody, right? So this means nobody, right? So this you cannot donate 2 cedis to nobody. It doesn't work like that, right? So with something like this, the limit here helps us to come up with our best prediction, right? So let's say I have a function. I have a function that goes like this. Maybe let's say x squared plus 1, everything divided by x here. So this is a pure simple question. Why s goes to goes to 0, right? So this is what we are seeing. So at the point of 0, meaning that we did not observe what happens at the point 0, right? So we did not observe what happens here. So what will be our best prediction? Right, so here you can say that the limit as s approaches 0, right? That is what we are doing. So looking at this function here, you can say your first step in solving this thing is to try and plug in, right? So plug in the values of the x here and see if you can have an answer. So what I mean about, if what happens if you can see everything clearly, right? So you can see everything clearly, so we don't need a prediction. So if you can see everything that happens, this is what I'm trying to say. So let's say I have a limit as s approaches 1 of, let's say, x squared plus 1, right? So this is a function, right? So at point what 1 here, at point 1, maybe in the first second here, or maybe in the first 1 minute, assuming we want to predict what happens with this function, right? So we are going to predict and say that at what point 1 here, what happens if you can see everything clear. So of course you have to plug in these values of the x into the function. That's the case of 1 everything squared and then plus 1, so this is equal to 2, right? So if I can see everything clearly, I don't need this or this limit, right? So that is the assumption, the idea behind. So what happens if you have something like this, a limit as s approaches 1 of x squared plus 1 on what, let's say x minus 1, right? So something of this nature, right? Is that okay? Something of this nature. Now the key here is that can I plug in this x here equal to 1 into this function and have my answer now. So let's try. So here is going to be, suppose we are solving, so whatever you see the x, we are going to replace that by 1, right? That is where we want to show our prediction. So we have 1 squared here, then plus 1 on what 1 minus 1. You can see that we are going to divide by 0. This is exactly what I started at the beginning, right? This is not possible in mathematics. So what will be our best prediction at point what 1, right? Relating to this function, that's what you are trying to say. So your best assumption, your best prediction, that is where the limit comes in, right? So that is where the limit is very, very important. So the key here is to try to zoom in across the points that are coming from either both left and right of what 1, right? So anywhere that these people are coming. So our best prediction within that interval is the most important thing here. So the way of doing that is to manipulate this function for us to take that 0 out there, right? So you have to here the key here is that we are going to solve more questions on this limit. So make sure that you subscribe to the channel for more content like this. So the way of manipulating and zooming in is what, make sure that you are not going to divide by 0. That is one step, right? So how do you do that? Here you can see clearly that this can be affected into 2, right? So this is just for an understanding purpose. So you have a rare questions on the channel. That is why you need to stay to the end, or you subscribe to the channel and check our playlist down below. So anytime we release a new video, you can get it. That is one step. This is what another black hole. So talking about the black hole here, right? So you've already seen the case where we are going to divide by 0. Is that okay? So this is another black hole in mathematics. So this thing stands for infinity, right? So up to infinity means that we are going to a very large number, right? A very large number that you can think of that has no end, right? Anything that you can, any large number that you can think of, right? And so on and so forth. That is what we are calling what infinity. So the way of solving this problem, that is why the limit has to come in for us to have our best prediction. What happens if you are going approach to what a certain number, infinity, so up to any huge number that you can think of, right? So those are the 3 things that are most important, is very crucial in limit. 1, to show our best prediction of what, whereby they are black holes, so division by 0, and then what, for infinity. If you want to know how to solve this thing, right, there's a lay down procedure. So by the way, so the first step here is that you have to divide by the highest power of the x in, is it the meaning of that? What I mean by the highest power is that, so if you have x raised to the power 1 here, I don't have any other x here, so the highest power is the exponent here, which is 1, right? So what about this x exponent? This is the highest power here, so s is 2. So if you combine everything together, s on what, s square here. So if you have, I want to determine the limit as this guy here goes to what, infinity, then I'm going to divide. Let's add a limit to this before we come back to our question. So the limiter, so this thing approaches infinity. So we are going to divide everything here by the highest power of the x, which is x raised to the power 2, right? So the idea here is that we are going to divide everything by the highest power here. So you have the limit as s goes to infinity. So as we are approaching a very large number here, so this guy on top here divided by the highest power. So what is the highest power here? That is the x here, right? So the x here, and then down here everything divided by what? X on what? On our x, and then plus 2 on what? On x, right? So let's see how to add that here. So here is divided by x and divided by x, right? So this happens if you are going to what? Infinity, right? So we are going to approach a very large number. So the only thing here is that we are trying to make sure that we are omitting that something that we did not see. Is that okay? That's the best prediction. So here we know how to solve this. This one and this one goes away. This and this comes to 1, and then we are left with this, right? So now we are going to left it the limit as s goes to any infinity here. So the top here is left with 3, right? Everything onward here will be 1, and then plus 2 onward on x. So there's x there, right? So there's x there. Is that okay? Now how can we proceed from this point? Now look at something. Only this one. This is our headache now, right? So this is where we are having the issue. So assuming, remember where the x is coming from. The x is going to a very infinite, right? So a very large number. So if you say I want to divide 2 by 1,000, right? So 1,000, what happens? So maybe this can be a very small number, right? What happens if I add 0.0000000 to what? To this thing, right? So this is going to be small, right? So you can see that else the number is very huge here. So the answer is going to be 0.0000 something. So we can say that the limit of this one goes to infinity, right? So we are dividing by infinity here. So a very large number, of course, is going to be 0, right? That is definition, because once the number on the top here is being divided by a very large number at the denominator, everything is going to be 0 gradually, right? So here we can say that the answer to the guy at the down here, so the limit as s goes to infinity of 3 on 1. So this everything here plus 0, right? So we can see that because the number at the down here is very huge. So here is going to be what? 3 on 1, that is equal to 3, right? So that is the idea of a limit in mathematics. We have if you want to know the technical definitions of these things, make sure that you subscribe to the channel, right? So this is just the foundation or the beginning. We have a special gift for you at the end of the video, so try and watch that if you are interested in any of our products.
Are you a high school math guru? Do you belong to a high school math club? Or do you know someone special in high school you want to express your gratitude? What about showing appreciation or encouragement to a friend or relative in a form of a gift? Will you soon graduate from high school? Then congratulations in advance. What if you guys are in uniform? Great, right? You may check our store in the description below for nice shirts and more. We love you.